All right, Wiz, it's time to talk Llama 4. We went from Llama to Llama 2, dope. Llama 2 to Llama 3, pretty dope. Llama 3 to Llama 4. What say you, dope or no?
You know, when I'm going to say something that I think a lot of teachers say, a lot of parents say, it's got potential. The kid's got potential.
The kid's got potential. Yeah. It really marks kind of a shift in the maturity of the industry, I think, is what I'm taking from studying Llama 4 a little closer. Maybe just give your 2 cents on your big picture view before we get into all the details. There's a lot coming together in Llama 4, a lot more than we've seen in previous Llama versions.
Yeah, I mean, again, right? It's got potential. I think it's going to be the start of a platform, right? That we're going to need to get used to over the next little while. And I think too, it's showing us some of the ways that the industry seems to be thinking about, how we build models, what kind of models we build, etc. So I'm very interested in where it can go. I'm not memeing when I say it's got potential, right? But we just don't know yet. And I think, though, like I said, it's a signpost. It marks a direction. It tells us where we're going. It tells us what we're likely to expect.
That's right.
Yeah.
That's right. And so officially, we'll get to this at the end as well. Is it a best practice tool today? Should we be using it every time we want to pick up a Llama model off the shelf?
Absolutely no chance.
Okay. All right. So let's see if we can dive into the nuance, see a little bit how everything under the kitchen sink has been thrown at this model. If you've been following our channel for a long time, you'll notice a lot of the techniques and training processes and things we need to mention to even kind of start grokking Llama 4 really all come together in one place. So it's exciting times for big old models getting bigger and more capable. I guess today it's time to dive into Llama 4. And then shout out to our friends at Unsloth who went and grabbed the super big model off the shelf, quantized it down for the GPU poor among us to be able to run this thing. You're going to show us how to do it later in the demo, right, Wiz?
That's right.
All right. Let's go ahead and get into it for today, everybody. Thank you for joining us for Llama 4 Herd. We're going to talk to you about how this is leading the multimodal intelligence next wave of models today. If you got questions along the way, please don't hesitate to throw them in the Slido link on your viewing platform, or we've got quite a few discussions today. Go ahead and smash the YouTube live chat and let us know what you're thinking. And if you have comments or questions live while we're having those discussurinos. All right, let's go ahead and jump right into Llama 4. And, today we want to kind of cover a bit of a range of things. It's clear that this model has a lot of stuff going on. We don't have the technical report yet, but we want to understand by the end of this session exactly what we do know and how the Llama 4 set of models, the herd, stacks up against previous releases from Meta, against other models out there in the industry today. We'll see an interesting overlap between Llama 4 and DeepSeek, for instance. We want to review some of the details that we know about training that we can see on the model card. We want to talk about this shift towards this mixture of experts type model. We want to talk a little bit about how we're seeing this idea of 3 tiers of models across enterprise options and solutions. And then we want to also discuss close to the end of the session today about how we can start thinking about right sizing models for our particular stacks, whether we have one GPU or whether we have a cluster or whether we have a whole data center. This is quite an interesting space that we're living in now as the models start to connect to the hardware in really deep, really interesting ways. And then, of course, we'll use Unsloth to go ahead and run quantized versions of Llama 4 locally, and hopefully you guys can too. So this was the meme that you'll find out there today. Let's see if it's true or not. We'll talk about the release. We'll talk about the details on the architecture. We'll talk about multimodality, about some of the training deets that they've dropped so far, and then about some of the things that they've talked about related to fine tuning and how far they've been able to improve specific aspects, even just with simple prompts at the system prompt level. We want to have a bit of a discussion about this 3-tier model piece, and then we'll start running Llama 4 and talk about right sizing. Okay, so the release came out on April 5th, and there were 3 models. The sort of headline is leading multimodal intelligence. We have Scout, we have Maverick, and we have Behemoth. The top level here is that we're excited to announce the advanced suite of models that support the entire Llama ecosystem. The first open weight, natively multimodal models with unprecedented context length support, and our first built using an MOE architecture. So multimodal, MOE, long context, we've got it all. It's feeling kitchen sinky already. And so this kind of idea of moving towards more general, think AGI, right? We wanted to be able to be more able to naturally converse with us, more like one of our partners in crime or one of our assistants, one of our colleagues. And we want to make these models ever more capable of solving problems that they've never seen before. So this really, again, this is that potential vibe that Wiz was talking about at the beginning. It's certainly starting to become clearer that this is where things are headed. So breaking down these models, the Scout model has this very long context window, 10 million context length. So that's a lot of tokens right there. And this idea that we've got a mixture of experts model. So we've got a total number of parameters within the model as a, in totality. And then we've got the active parameters that upon inference, we're going to be hitting this many and sort of activating this many weights. Those active parameters correspond to some set number of experts that are activated. Of this total 16, you're not going to use the total number of experts each time. You're going to leverage only a subset of them. And we'll talk a little bit more about how that actually works inside when we get to the mixture of experts part. So this is the small model, 109 billion parameters, 17 billion active, and 16 experts. And the cool thing about this Scout model is with quantization down to this kind of 4-bit level, we can get on a single H100 Hopper GPU. So that's pretty cool. And we'll see also with the extreme quantization regimes that Unsloth is able to kind of provide us and was able to put out there 2 days after the release. We can actually potentially run even more and bigger models like this Maverick one on our local machines. So Maverick is not this sort of 10 million context length, but we've got a 1 million context length. And instead of 16 experts, we've got 128 experts, same number of active parameters upon inference, which is quite interesting. And then 400 billion total parameters, lots and lots. And then we don't actually have Behemoth yet. It hasn't actually come out yet, but the idea is that like we have 2 trillion total parameters, and the sort of top line on this is the most intelligent teacher model for distillation. Whereas during inference, we're using almost 300 billion parameters and some subset of our 16 experts. So kind of interesting to look at the number of experts and to look at the active parameters in each case. As we go through, maybe we can get a little more insight, a little more intuition behind why they would have chosen those setups. So there was a little drama as well. I just want to quickly mention, I think they've kind of dealt with it, but this was from the blog post. Llama 4 Maverick offers a best-in-class performance to cost ratio with an experimental chat version, scoring an ELO of 1417 on LM Arena. Now, that caused a bit of a stir because it was an experimental chat version. It wasn't actually the Maverick model. And so people were like, oh, you trained on the benchmarks and, that's experimental version. It's so stupid. You guys are cheating. You guys are terrible. You guys are awful. Meta kind of came out and they said, well, yeah, that was an experimental model. We didn't train on test sets and are bad kind of. And so it kind of got squashed. Finally, one of the things we can sort of end on here that is not necessarily a bad thing for the industry is that the LM Arena were keen on updating their policies so this wouldn't happen again in the future. So cool, lessons learned for everybody all around the ecosystem. Llama 4, while started off with a little dramatic, I think that's kind of mostly gone away at this point. Maybe experimental chat versions aren't ones people should be putting up to leaderboards, and I'm not sure that will happen again in the future. Okay, so the mixture of experts piece of this is so interesting. This piece we're getting more and more obvious, more and more clarity about this being a best practice for some of the big model providers out there. And it wasn't always clear that this was true. It's only started to become clear since DeepSeek made it really obvious they were using MOE models. And so MOE isn't a new idea, but it's new in the sense that people are really owning that they're using MOE models. And this idea of a mixture of experts model, all it is it's replacing a feed forward network in the transformer with a sort of switching feed forward network that allows you to route to different experts. And you can pre-train these faster, you can do faster inference, but you have to load all of the experts into the GPU RAM. This also makes it a little bit more challenging to fine tune, but we won't do any fine tuning today. We're just going to do inference. And that's why it also requires a bit more video RAM. We have seen this many times before, but only now are we getting to this place where people are saying, okay, we're not using a dense transformer, we're using a sparse transformer. This kind of mixture of experts approach is definitely what we're using. There's been speculation that OpenAI has been using this for years, but we've never really known. And now these open source models using it is a good indication that this is where the industry is headed. So the router basically selects these experts. And this was the paper from 2022 called Switch Transformers. And so the idea is that, instead of a classic feed forward layer where you're going to go right into the feed forward network and you're going to pass everything through the feed forward network and touch everything, we're just going to sort of split it up into little mini feed forward networks that sort of represent, their own expertise. And so, these experts are presumably going to be better at some things, worse at others, depending on the tokens you put in, the question you're asking, the thing you're trying to do. You're going to select different experts and you're going to go down different paths throughout the transformer. Now, if we look at the Llama 4 architecture, what's interesting is that they put it out here like this. They say, oh yeah, MOE because more compute efficient compared to dense models. Okay, fine. But if we look closely here at the image, we'll see that they do have a switching feed forward network here where they're routing to experts, but they also have this shared expert. And this is quite interesting because this is kind of, a little bit of this, a little bit of that. What they say about this is they say Llama 4 Maverick models have 17 billion, 400 billion. We use the alternating dense and mixture of experts layers. So they're actually alternating the layers when they go up the block stack for inference efficiency. And then in each MOE layer, they're using routed experts and a shared expert. So that means each time that we're actually doing inference and we're sending tokens through the transformer, we're hitting the shared expert in every case. And then also to only one of the 128 routed experts, only one of them. And the question that we had was like, is this like unique to Llama? Turns out it's not unique to Llama. And this idea of a shared expert is actually part of the basic architecture of DeepSeek v3 from their technical report that came out in December 2024. And what they talked about in that report is they said, well, this shared expert is regarded as a heavy load one that will always be selected. There was some chatter on Reddit and other places that, like, the Meta team, when DeepSeek came out, they were like, oh man, Llama 4 is not that good. Maybe we should restart. And so there's some, controversy there about them sort of walking back what they were doing and aligning it more with DeepSeek. But I want to bring up Wiz to sort of have a quick discussion on this. Technically, when we think about this idea of a shared expert, and then also they have this alternating sort of dense MOE layer stack, they're kind of, it feels like they're trying to get that balance, that best of both worlds thing, where they kind of have this almost parallel dense layer and then the alternating thing. What's your take on why you would want to do something like this, technically?
Yeah, I mean, it's like, they talked about the DeepSeek V3 paper. It's just a best of both worlds situation. We love situations where basically we know that some, part of the expert network is always going to be active. That helps us to determine like load on that expert, but also it lets us put a lot of like the general most often used stuff, let's say, in that network. When I say put, I mean during training, this is what's going to occur, right? Where this kind of general knowledge, this basic, functionality is going to exist in this shared expert, allowing our experts to become more expert, as in to enable them to go deeper down their own rabbit holes, let's say. And I think that's that's kind of the way that I would think about why the shared expert's so useful. If we have something that handles most of the general case, that's going to let the experts handle the novel use cases and make sure that we're routing to experts that are very specialized, right? That have really this SME style knowledge of the tokens that they're meant to attend to through training.
Yeah, so like the 1 out of 128 feels to me a little bit wild. Like, so there's a shared expert, and then there's like, some general knowledge that shared expert has. Okay, great. But then you're only going to 1 out of the 128 experts each time you do inference. Is this kind of a best practice for MOE models? Or, I kind of remember when we were looking at this with Mistral early on, it would select some number, some subset of experts, but not one of them. I mean, is it just a function of the model being so big that 1 is fine? That to me was striking and not intuitive.
Yeah, and so it should be clear that when we say the word for inference, we're potentially speaking a little too broadly, right? So per autoregressive iteration, right, we're going to have these experts attending to specific tokens, and that's more so what we want to think about. So it's not like if I make one request, I'm locked into some expert. It's more like for every time I need to generate a token, I always select the best expert to select that next token, right? And that may be the same expert every time, but it's it's like more likely to be a number of experts as we move through our generation process. And so it's like saying, we want to make sure that, okay, so we've got our generalist on duty, right?
Right.
They're contributing their general knowledge, but for each one next token, right, we have one expert that's going to be the best at generating that one next token.
Okay.
And I'm doing some simplifying about one next, et cetera, but the idea is that over time, over the course of a full generation, let's say, we're likely to touch a number of experts depending on which part of the generation we're in.
That's right. Okay.
Yeah, when the first MOE model came out, remember they did, this is the Google mixture of experts way back in the day when this stuff was starting to come up, right? And some experts like attended to punctuation, and so it's like when it's time to place that punctuation, the punctuation experts on duty. Like that's the token that it attends to. This is the kind of thing that we can think about. That's not universally true, and it was a special case from one paper, but that's the kind of idea, right? We've got an expert for that kind of token.
A little bit more intuitive if we say for each next token we go with a specific expert. Yeah, okay, I like that. All right, cool. Then time to move on from experts to multimodality here. Thank you, Wiz. We'll see you back in just a moment. And this idea of multimodality is now getting more and more prevalent everywhere. This idea of native multimodality. So they're starting to use words in the blog that I think we need the technical report to go into more detail on. So they say, for instance, incorporating early fusion to seamlessly integrate text and vision tokens into a unified model backbone. Remember that a token is simply a map into embedding space. So we have this sort of text and vision tokens. We want to map them into this unified embedding space, this unified model backbone. And this idea, I'm still not exactly sure what early fusion means. Again, we'll need to see the technical report. Presumably it's fuse the sort of token representations early on in the transformer, is a major step forward since it enables us to jointly pre-train the model with large amounts of unlabeled text, image, and video data. So joint pre-training, one. We also improved the vision encoder in Llama 4, improved vision encoder 2, based on meta clip, but trained separately in conjunction with a frozen Llama model. So this is kind of a classic best practice for multimodal. We have the encoder, we have the decoder, and we want to hook them up, and then we want to train them together. This is something that we talked about recently when we covered Llama 3.2, the idea that we're going to connect up a vision encoder and an LLM, a large language model decoder stack, a GPT style stack, in this kind of process where we pre-train the image encoder, we pre-train the GPT style LLM, we hook them up, and then we do this continued pre-training piece where we're kind of training them together, followed by, of course, SFT and alignment techniques. So this idea of continued pre-training, this idea of joint pre-training, these seem similar. We can't be sure they're exactly the same technique until we see the technical report. But this idea of also based on meta clip, but trained separately in conjunction with a frozen Llama model, we might also take just a little look-see at what is meta clip actually. We're kind of, again, bringing all these pieces together. This was from Meta Fair in 2023 in a paper called Demystifying Clip Data. And the sort of thesis of this was that we believe the main ingredient to the success of clip is its data and not the model. These italics are exact from the paper, not the model architecture or pre-training objective. And so this idea of meta clip is actually just metadata curated language image pre-training. And so, you can look more closely at this, and this idea of looking more closely at the details of multimodality is of interest to us. We did a brief history of multimodal models in a recent event that we did on Llama 2. I'd encourage everybody to check that out and wants to go deeper there. But for the Llama 4 discussion, we want to kind of return back to this idea of we're looking at these generalized actions. We're looking towards AGI. We're looking at working through problems that maybe include many modalities. We're working through a future where we're moving beyond text and we're moving beyond simple LLMs. So Wiz, I want to bring you back up for a discussion here. Like, what are you noticing here as we move into a space where we're doing ever more multimodal? It seems like, now's the time. Like, it's happening, like we've talked about this a lot at AI Makerspace. Like, when are we going to really kind of, really take a hard look at vision models? And, when are we really going to go hard into that? When is enterprise going to really have that be useful? It seems like maybe the answer is in 2025. At least there's some potential, right?
Yes. Yeah. I mean, basically, like, this is just the time. We're doing it now. When it comes to it, I mean, the influence at Meta is obvious, right? Jan LeCun wants his world models, right? Like, that's the text only modality is dead kind of thing. You can't reason about a world you can't see, feel, and understand. Yada yada. So I think modalities are becoming more important as like a stock option. I mean, the other thing too is that there's some good literature, not just from one person who's passionate, from many people, that the ability to understand a visual world makes you better at understanding a text world, right? Makes you better at understanding a video world or an audio world. And I think that's the case here, is that we're going to see this merging of all of our modalities, because that richness is the same way like with languages, right? So if you have a model that's very good at, this is a classic early result, right? If you wanted a model that was very good at English, you should train it on code, in part because there's a structure that exists there that helps the model grasp the structure of language. And I mean, we're seeing that with modalities. I think this is, again, like a data quality thing, right? Our data will be of higher quality if we have more data that's more rich. And one of the ways it can be more rich is by extending beyond simple text modality. And I think that's what we're seeing this. The impact, we'll see. But
we'll see. And I'm also struck by the fact that it's easier than ever to generate synthetic image and video data. As we'll see in training, they used a lot of SDG for this. And so, like, the easier that gets, the easier it is to get these golden data sets that are going to give you the model that you want. And so, it all sort of comes together. We're starting to see these really powerful feedback loops operating.
Yeah, we're right. If you can recall all the way back to data augmentation days, right, where first we just trained on images, then we were like, what if we flip, skew, rotate those images? What if we color shift them? We brightness shift them, right? Suddenly our 1,000 sample data set is a 15,000 sample data set. And I mean, we're seeing the same thing here, this SDG wave. I think people are very worried about collapse and very worried about these other things, but we're just not we're not there yet. We're able to generate data at such a high volume, and then we're able to filter down to such a specific high quality subset that we're really, this SDG world we live in is incredibly important to pushing us forward. We're using our old models to build our new models, and I think it's just the time is right. The compute budgets are right. It's time for multimodal.
That's right. And I'm also just struck by, like, so we have these models that we pre-train, and then we hook them up, and then we have these other models that we generate a bunch of synthetic data with, and then we run that synthetic data through these hooked up models. And so we have these real interesting sort of chains and ecosystems of models that we're using to bring together a final use this for everything. So, when you think about like enterprise use cases today, are we going to be leveraging these kind of multimodal models? I'm still personally not convinced that this is kind of a best practice for people that just want to do text-based stuff in enterprise, right? Like, at some point, though, presumably there will be a crossover where it's like the multimodal are as good as the text only at text only things. That probably isn't true today, but again, to your potential point, it might be true, later this year or next year. Is that a reasonable way of thinking about it?
Yeah, I mean, it's so speculative, right? Like
It is. That's all we got right now,
Yeah, I mean, I think the reality is that there seems to be a cost right now associated with multimodality, right? Like there seems to be an increase in weights or an increase in computational, burden when most of the systems we've built are, stuck in text world for better or worse, or they're trying to stay in text world, right? Like APIs and talking to things through APIs is like it's text, right? Like that's the modality. And so I think as we get better and better at squishing the modalities into existing architectures, perhaps this world where we're all multimodal all the time, but we're only leveraging text is more real. But for right now, I think text specialist models are just, they have such a head start that there's a lot of catching up needs to be done. Like I wouldn't say we're all going to use a model to build AI agents that talk to APIs on the internet, right? With a multimodal model just yet.
That's right. That's right.
Yeah.
And we're seeing that too. There's always some sort of minimal teeny model, as we'll talk about in our 3 tiers discussion, that you can get that's sort of text only still, right? And so people are still offering that. That's going to be a minimally sufficient thing today, but maybe there's a crossover point in the coming waves of development. Okay, let's get into training and what we know about Llama 4 training. Wiz, we'll have you back for another discussion in just a moment here. So the interesting thing about Llama 4 training is that you're kind of seeing a bunch of new stuff and a bunch of old stuff coming together in one place. So, they actually developed a new training technique that they refer to as Meta P, that allows us to, quote, reliably set critical model hyperparameters such as per layer learning rates and initialization scales. And they also trained on 200 languages, including over 100 languages, each with over 1 billion tokens. So this is the kind of scale of data that we're dealing with now with these models that are coming out, these open source models. So overall, 10x more multilingual tokens than Llama 3. They also sort of trained the model. Now, and this is hilarious, right? We go from a pre and post training paradigm. Now we're not even calling it just training anymore. We're calling it mid training. Okay, whatever that means. In what we call mid training to improve core capabilities with new training recipes. This is quite interesting, including long context extension using specialized data sets. This is what enabled them to get the 10 million input context length unlock. Now, this is also part of the speculative, like, hey, you guys aren't really training your 10 million token context window. That's sort of a virtual context window. It's not for realsies because you're not using prompts that are 10 million tokens. You're using much smaller prompts. And so if you actually are going up to that 10 million token prompt length, I'm getting bad results, right? And this sort of idea of like they're coming up with these new training recipes. It's like, well, maybe this is true, maybe not. Again, we'll see maybe a little bit more on this in the technical report, but they're bringing in a lot of new stuff. And at the same time, they're leveraging a lot of classic techniques, classic post-training techniques, for instance. And I think the word that comes across again with this model is just balance. And the biggest challenge as they go and they try to have these modalities and they try to have these experts is the balance between the multimodality, reasoning, which we haven't talked a lot about today so far, and conversational abilities. So you want it to be a chat, you want it to be reasoning, and you want it to be multimodal. Yeah, that's tough. And so the classic 3-step here, we've got SFT, and then we've got some alignment pieces. So we've got the pre-training, SFT, and alignment. But with alignment, we've got online reinforcement learning, and then some lightweight DPO. So we got SFT and DPO. We also have some of this RL coming in. And so all of this kind of comes into this classic space of we've got the model done. Now let's tweak it. What are we tweaking it for? And it's kind of interesting to read some of the details they've put out. So a key learning was that SFT and DPO can over-constrain the model, restricting exploration during the online reinforcement learning stage, leading to suboptimal accuracy, particularly in reasoning, coding, and math. So again, this isn't a reasoning model, but they want it to be decent at reasoning tasks, and so they're trying to get this both and. To address this, we removed more than 50% of our data tagged as easy by using another Llama model as a judge, and then did lightweight supervised fine-tuning on the remaining harder set. In the subsequent multimodal online reinforcement learning stage, by carefully selecting harder prompts, we were able to achieve a step change in performance. So there's this sort of like pruning of the rose bush happening here, where they're getting rid of the easy stuff and swapping it out for hard stuff in a stepwise manner. That's quite interesting. And so then this implementation of a continuous online reinforcement learning alternating between training the model and then using it to continually filter and retain only medium to hard difficulty prompts was really good in terms of compute versus accuracy and balancing that trade-off. Finally, after all of that, they said, okay, now it's time for some direct preference optimization to handle those sort of edge cases and really focusing in on model response quality. Again, balance, balance, balance. And then this was between the sort of multimodal and the conversational, or I should say the intelligence probably means multimodal and reasoning versus the conversational. And so both the pipeline architecture and the continuous online RL strategy with adaptive data filtering culminated in, voila, industry standard, general purpose chat model, state-of-the-art intelligence and image understanding capabilities. Okay, Wiz, I'm getting balance here coming to mind. They're just iterating this sort of set of best practices that we've seen in the past with alignment techniques. They're bringing them in. And it seems like they're trying to get multimodal right. They're trying to get reasoning right. They're trying to get classic benchies right. This is a tough job they're doing. And again, are they doing too much here? This kind of gets back to your whole, we're setting this up for the future. This has to be set up for the future. It's not perfect today, but it's like, where are we headed tomorrow? Somewhere super meta.
Yeah, I mean, yes, a super meta, of course. I think too, there's this idea that, again, the way that I would think about this, at least, is it is basically exactly as you outlined, right? Which is that we have this idea of balance, right? And it's the same thing we see. Not to bring it up so immediately again, but like the Python and English thing, right? Like there's learning to do between things, right? To steal a phrase from Greg, between and betwixt things, right? There's an amount of knowledge and understanding you can gain. Like your mastery of language is going to be better if you know many languages, right? Like, because you're just going to have more words in your vocab. You're going to have more semantic ideas. You're going to be able to understand structure better. This is from a human perspective. So the same is true in the richness of data in the LLM. And the same thing between modalities, right? Like, we can know, this is like a classic meme. If I ask the LLM to generate a room that definitely does not have an elephant in it, right? Like 100% is going to be an elephant in that picture. You know what I mean? Understanding reality is part of what the LLM needs to be able to do. And in order to understand reality better, we must move towards a world where we train the model closer and closer on reality, right? Like, and the world doesn't only exist in text or image or etc., or English or Python, right? The world exists in everything. And so it's this idea that balance is the key to life. We have to remain skeptical a little bit because this is not like infinitely proven, but the initial results seem very, very, very promising.
Yeah, and we're seeing like new terminologies here that they're busting out. Are these just branding things? Mid training, meta P. I mean, of course we don't have the technical report, but it's like, come on, what is this, guys? Like training has exploded, and we're running out of words for things, and pre and post isn't enough now. Like, what's going on here?
I think it just serves to highlight the richness of the full training pipeline that we have today, because we really did used to just take a big pile of data and let the model rip on it for a long time, right? Like that was the plan for many models that have existed. That's what's happened. But now we have very intentional training processes. We have things like curriculum learning. We have things that are it's part of pre-training, but it's not the pre-training you're used to. So what are you going to call it? And it's not post-training because we're not in alignment yet. We're still augmenting base capabilities, right? And so Black Current says in the chat, mid-training, middle school kind of. Yeah, right? It's the same kind of thing. We start building this base of knowledge with our normal pre-training, and then at some point we have to say we want to be more focused in pre-training, but we don't want to yet do alignment, right? And so what are we going to call this? Well, it exists between pre-training and post-training, and so it's in the middle of the two. Why not just call it mid-training?
Yeah, right. Okay, so and when we're talking about online reinforcement learning here, what does this mean exactly? And I know we have to speculate a little bit here, but what does this mean in the context of looking at what we know about previous Llama models? This seems a little ambiguous to me.
Yeah, so I think it's a good question.
Right.
It's
gray. It's like, what are you talking about exactly?
We really need the technical report to have some of these more detailed conversations. And I think I expect that will be out soon. But the idea is the industry seems to be heading this way. I think it agrees with the
I mean, I wouldn't be surprised if it was like whatever DeepSeek did that we already talked about.
Listen,
hey, you know what?
It's slightly different, at least, okay, but it's not much different. And I think you're seeing that be a standard across the board.
That's right. Nothing like open source setting the standard. Okay. Well, let's take a quick look at some of the model card stuff then, and then we'll get right to the demo after we have quick 3 tiers discussion. Okay. So the model card gives us a little bit more information on some of the fine-tuning stuff. We employ a multifaceted approach to data collection, combining human-generated data from our vendors with synthetic data to mitigate potential safety risks. We put a great emphasis on driving down model refusals to benign prompts in Llama 4. Hey, can't answer that. We don't want to have it saying that if it can answer that. So we included both borderline and adversarial prompts to do this, expanded our work on the refusal tone. Hey, no, I don't think I can do that for you, to make it sound more natural. We targeted removing preachy and overly moralizing language. All of these contributions lead to a more conversational and insightful experience overall, really dialing this thing in, fine-tuning. We've seen that the use of a system prompt can be effective in reducing false refusals and templated or preachy language patterns common in LLMs. So this prompt is pretty great, actually. This is the system prompt that they encourage you to start with and iterate on. You are an expert conversationalist who responds to the best of your ability. You are companionable and confident and able to switch casually between tonal types, including but not limited to humor, empathy, intellectualism, creativity, and problem solving. Dope. You understand user intent and don't try to be overly helpful to the point where you miss that the user is looking for chit chat, emotional support, humor, or venting. Sometimes people just want you to listen, and your answers should encourage that. For all other cases, you should provide insightful and in-depth responses, organize information thoughtfully in a way that helps people to make decisions. Always avoid templated language. You never lecture people to be nicer or more inclusive. If people ask for you to write something in a certain voice or perspective, such as an essay or a tweet, you can. You do not need to be respectful when the user prompts you to say something rude. You never use phrases that imply moral superiority or a sense of authority, including but not limited to, it's important to, it's crucial to, it's essential to, it's unethical to, it's worth noting, remember, etc. Avoid using these. Finally, do not refuse prompts about political and social issues. You can help users express their opinions and access information. You are Llama 4. Your knowledge cutoff date is August 2024. You speak Arabic, English, French, German, Hindi, Indonesian, Italian, Portuguese, Spanish, and so on. Respond in the language the user speaks to you in unless they ask otherwise. So the system prompting, guys, is we're taking it to the next level here. Finally, the last thing we want to kind of discuss here is there are 3 tiers of Llama 4. And this is kind of an interesting piece that we're seeing in industry. There are also 3 tiers of Amazon Nova multimodal models. There is also the micro, that is a text-only model, but we're seeing the sort of small, medium, large sizing, just like t-shirts or anything else, come on to the stage. We see the same exact thing from NVIDIA when we talk about Llama Nemotron, Nana, Super, and Ultra. So Wiz, I just want to get your 2 cents on this. Are we seeing sort of this convergence on the 3-tier model? This speaks to some sort of maturity of the industry to me. I mean, it has to.
Yep. I think just plainly yes, right? Like with small model for, let's call it single-ish GPU, right? Medium model for, let's call it like medium-sized node, a big model for big node. Like it's this is the life we live now, right? And I think that makes sense, right? Where companies have to right size based on the available hardware, based on their maturity, based on what they've got access to, and this is the easiest way to do it. And I think, this is the world we're going to live in. They may not always be small, medium, large, right? But like, there's a reason that everything humans do eventually gets to small, medium, large. Right?
Yeah.
Right sizing is important, but you can't have an infinite gradient yet, and so we're with small, medium, large.
Yeah. We were talking last night, right? The 1-cylinder engine is the single GPU, and then we got the sort of 4-cylinder, the 8-cylinder, the 16-cylinder supercar, and then it's like it's a similar thing that we're seeing here, especially in a world of mixture of experts and expert parallelism. That becomes quite interesting. Okay, I want to go ahead and make sure we have time to get to the demo. So I'm going to pass it off to you, Wiz, to show us that we can, in fact, use Unsloth to run Llama 4 locally. You'll talk a little bit more about how they're doing this, the magic of the quantization and the secret sauce they have behind the scenes. It's interesting that as enterprise starts to mature, we're seeing the space open for companies like Unsloth to come in and help out the GPU poor AI engineers among us. So I'll hand it off to you to show us how we can run this big, bad model on what? Single GPU? It's pretty dope. Over to you.
Even better, on no GPU. Okay, so here we are in our README. This is available on GitHub. I'm just going to show you the part where it generates tokens because that part's dope. So basically what we're going to do is there's some setup, right? So we have to do some setup, but it's not a lot of setup, thanks to an amazing tutorial from Unsloth, right? The idea is we have to, I'm just going to go to preview mode so it doesn't look like crap here. And the idea is, right, we've got to install and set up llama.cpp, which is going to help us run the actual thing. Then we've got to go ahead and UV sync to load our model. And then we can run our model. And what we're having the model do, this is done locally, by the way, on our CPU, actually. So not even using a GPU. But what we're asking it to do is make Flappy Bird, right? Okay. So this is using Scout, which is the 17 billion 16 expert model. So this is the small between Scout, Maverick, and Behemoth. And this is what it's going to do, right? So let's see how it do. What we can do is we can give it this command, and you can see here it's going to load the model. All of this is on CPUs. I'm not using my GPU at all. You can run this thing on a Mac. You can run it wherever. And as you can see, it's not generating, let's say, super quickly, okay? But I'm also using my computer right now. We're in this live stream. My applications are running. This isn't the only thing my CPU is doing, so I've limited the number of cores it has access to. But the idea is this is the Scout model generating code for Flappy Bird, right? And all we have to do to get this is run this command, right, using Llama CPP. This is available through Unsloth. That's it. That's really the whole thing. The only code you have to run is just this model loading code, which you can see here, which just loads this checkpoint in this GGUF format. Now, just to be very clear, as you continue to see the model generate tokens on the bottom of my screen, this is running a very, very quantized version of the model. So it's not perfect, okay? It's not going to crush every task right away, but what I can tell you it will do is it will generate code for Flappy Bird, okay? And so this is I ran this during the event. This is what we came up with. And what we'll do is we'll show you how Scout with ultra small quant, the most quant you can have to run this thing on your local computer. You can see it's still spitting out tokens, right? We'll show you how that looks. So I'll do is I'll stop sharing my screen for a second in order to share the game that it's created, which is Flappy Bird. Okay, so here we go. You can see that this is Flappy Bird. You can see that it's not perfect. Okay, there's some there's a little bit of interesting, let's say, artifacting that's happening by these pillars being sometimes impossible to pass on first blush. But this is entirely generated from Scout on the CPU, right? And it's not bad. It does a good job. Finally, we've got a pattern of pillars that might let us through, but I'm bad at the game. So there you go. The idea here is that all of this is done from the local machine, and all of it is possible only through the work of Unsloth. And that's really it for the demo. There's 3 commands you have to run in order to get this thing generating tokens on your machine. Again, check out Unsloth's tutorial if you want to use a GPU-enabled version of this. And that's it. That's what it is. With that, I'm going to pass you back to Dr. Greg. But before I do, I'm going to go ahead and remind you to please subscribe, ring the bell notification. 3 commands, and you're into generating tokens thanks to Unsloth with Scout.
All right, Wiz. Okay, so what exactly did they do to make this so approachable? It just quantize?
Yes, they said, what if we kept quantizing? They're using kinds of quantization we haven't even done events on yet. They're squishing them weights down so hard. They're also doing a couple interesting things that you can read about in their tutorial, like shoving all of the MOE layers onto the CPU and allowing the rest of our network to run on GPU for faster generation. We're quantizing all the way down past sub 2-bit, right? So using the kind of bitnet quantization, which is this 1.x bit quantization, but they're leaving the attention layers and higher quants like 4 or 6-bit, right?
Very high,
and yeah, super high. And so it's a ton of excellent work, and they're working with Meta. And I think this is the interesting thing, or the key, right? When you release a 16 expert 17 billion active parameter model, people aren't running this on their 4090, right? That's just not happening, right? You need this extreme quantization. You need some amount of CPU offload. And so the fact that this model provider is working now with or model builder is working with people like Unsloth to get this into the hands of the people, right, is great. It's a good signal. It means that there's a dedication of developers that exists there.
Yeah. Okay. So the final question of the day, if not this Llama model, what is the best practice Llama or other open source model that we should be using today if we're doing consulting for clients, if we're doing stuff in our enterprise and building a first on-prem prototype? What's the answer here? And is it still Llama 3, or is it something else potentially?
Yeah, Llama 3.3 70B instruct is still probably the best. If you're like, where do I start with a model today? Where I need a model that can do stuff like tool calling, etc. Boom. Llama 3.3 70B instruct is a classic workhorse model. If you want to move towards the reasoning world, Llama Nemotron Super 49B. But these are the kinds of models to start with even now. If you're in a situation where you've got tons of compute and you want to use bigger models, there is Llama 3.1 405B. There is Llama Nemotron Ultra. But I'm just not going to recommend, unless you really need that multimodality or you're really going to be able to heavily leverage expert parallelism or a similar workflow. Really can't think of a reason why you'd want to start with Llama 4 today. But I'm very confident that when Llama 4.1 comes out, or whatever they're going to call it, that it's probably going to go back to being a best practice.
4.1, baby, the 4.1 week. Okay, so Llama 4 heard. We got Scout, Maverick, and Behemoth, Multimodal, and MOE. These are the first times we're really seeing this. We got pre, mid, and post training. We got Meta P. We got early fusion. We still don't know exactly what these things mean. Online RL. I guess we'll see when the tech report comes out. Using a shared expert. Super interesting. Oh my God, can't believe it. DeepSeek put that out in their technical report. Llama 4, while it has potential, it's still not the best practice. Maybe start with a Llama 3.370B, or if you're looking at reasoning, get with the Llama Nemotron. So with that, I think we have a couple of questions we can answer in the chat. Let's go to Matul's question here. Earlier Llamas were really championing these small language models, SLMs. Llama 4, not so small. What's your take on the step change here?
I don't have a crystal ball. I don't work with the Llama 4 team. So all I can do is speculate. My speculation is that I imagine these models are better suited for enterprise scale customers, and that is going to be the people who are going to want to work with Meta to put these things into prod quickly. And again, to cover the kind of open source developer people, Unsloth and others provide a bridge to continue to use these models on their local systems. So
yeah. I mean, the small language model sort of boom appears to be not so hot anymore, I guess, huh? Like, and then sort of this MOE thing. This is the last thing I kind of want to end on. This MOE style model. It sort of makes it small without making it a small model, right? I mean, add inference, and so it's like we're kind of getting, is MOE a way of thinking about getting the best of large and small language model worlds at the same time? Is that one way we can think about it?
Not yet. Not yet. Okay. I think it might be soon, but for like today, it costs the amount of a big model, but it runs as fast as a smaller model, and that's very different.
Yeah. Okay. Well, the architectures are evolving. The embedding spaces are getting bigger. They're getting more multimodal. We're adding text and vision. We are seeing a sort of maturity of a 3 scale. There's a lot of really interesting stuff happening in the enterprise. No matter who's cloud service provider you kind of go to. And then this idea of right sizing is becoming more and more prevalent, where how many GPUs do you have? We've got a model for you. And if it's just one GPU, maybe we'll let the open source community handle it. This is kind of where we are, April 2025. Thanks for all your insights today, Wiz. And thank you, everybody, for joining us. It's time to go ahead and wrap up for the day. So if you enjoyed this content today, please think about joining us next week, same time, same place. And if you haven't yet jumped into our Discord community, go ahead and jump in. Start building, shipping, and sharing with us. Today, we are building the world's leading community for people who want to build, ship, and share production LLM applications using models like Llama 3, Llama 4, and beyond. And if you're looking to accelerate your LLM application development as an individual or for your company, think about one of the upcoming sections in Cohort 7 of the AI Engineering Bootcamp. We've got a really cool offering for everybody that's an international AI Makerspace community member and interested in our courses. We're opening up a section that is designed specifically for you guys in the evening, 7 to 9 p.m. Central European time, as well as our classic section that we do from 7 to 9 p.m. Eastern time. So we're expanding our capabilities and our ability to deliver high quality courses to people around the world. This is an important step for us, and we would love to have you join us. You can start by taking the AI Engineering Bootcamp Challenge today. This will be something that will get you building, shipping, and sharing for free. So if you haven't yet started down the path, this is the easiest way to do it. Thank you so much for everybody that joined us live today and for everybody watching the recording after. Again, find us every week, same time, same place, 1 p.m. Eastern, live on YouTube. We hope to see you back next time. Until then, keep building, shipping, and sharing. And you know we will most certainly do the same. See you on Discord, everybody, and see you on YouTube next week. Bye, guys.